Okay, so I was asked here a question from last year's half yearly. What are the asymptotes of this curve? Sorry, it's a multiple choice question here, and the answer is fairly easy deducible. But I think the main thrust, the main 2 points of contention will be obviously vertical asymptote where the denominator has issues. Yeah, where x plus 1 and x plus 2 are 0, i.e. at x equals -1 and x equals -2. I think probably that that seems quite clear to most of you. But the next question being the horizontal asymptotes. So the horizontal asymptotes are given from the limits, basically. So you're looking for, as x tends to infinity, then you've got, well, it's maybe better written as 3x over x squared plus 3x plus 2 tends to 0, basically. There's more work to do there. You can treat it as an actual limit. It might be better to treat it as an actual limit. You might actually say, well, what is the limit as x approaches infinity of that expression, which you can rewrite as the limit as x approaches infinity of 3 over x plus 3 plus 2 on x if you divide the numerator and denominator by the highest power of x that you can find in the numerator is a trick there. And so that would, when you then take that limit, that equals 3 over some infinitely large number, which doesn't really make sense. So you would then say, well, in that case, the limit is 0. The other trick, which is, there's some questions about the orthodoxy of these two approaches, in that you could say, well, that equals dividing by the highest power of x in the denominator will give you a finite denominator. So you've got 3 on x over 1 plus 3 on x plus 2 on x squared, and that gives you the limit 0 over 1 plus 0, which is clearly the number 0. It's a little bit less subtle. It's a little bit less subtle than doing it this way. As x approaches infinity, then 3x on x squared plus 3x plus 2 approaches 0 from above, in that you're getting a sequence of positive values in ratio, but clearly the denominator is going to overwhelm the numerator in terms of its magnitude, and therefore you're going to divide a number by a massively larger number, therefore tending to 0, but a positive type of 0. Whereas as x approaches negative infinity, you're still going to have this. I would perhaps reframe it as that. What have we got? We've got two negative numbers multiplied by each other, therefore giving an enormously positive number, and then so that's on the denominator, and then a large negative number on the numerator, but the denominator is dwarfing that. So your final result is going to be a tiny negative number. You're going to approach 0 from below. Why do I say this is more subtle than the limit itself? Well, the limit just gives you the value. This notation, as x tends to, you can actually notate the side of the asymptote which the curve is using to approach. So then when you actually ask yourself, what does that mean in terms of an actual graph? This is going to be a graph that looks like what? We've got asymptotes at, was it -1 and -2? So I'm just going to draw those in dotted lines quickly. So that's going to be x equals -1. That's going to be x equals -2. But also you have an intercept at the origin. If you sub in x equals 0, I need to see the equation at all times. It's a bit confusing not to have it there. When you let x equal 0, you get y equals 0. So there is an intercept at the, there is an intercept at the origin. here, okay, if this is the y-axis now, you're going to be over here at tending, basically what do our little pieces of detective work tell us? We're tending to 0 from above. Over here, we're tending to 0 from below. Over here, we've got vertical asymptotes in the middle. A little bit of sign analysis will tell you there's really 3 factors here. And obviously, when all 3 are positive, this curve is going to be only in the positive domain over here. It's probably helpful if I notate where these are, -1, 0, -1, and 2. All 3 are positive, then it's going to be negative in this region. So it's going to be up here, then down here, then up here, then down here, basically, is the nature of that. So how does that actually work? Well, I'm going to sketch it in green. I'll sketch it in green. The curve starts here, starts here, will reach some sort of maximum, pass through the origin, and then tend to negative infinity there. It's not going to be a very nice looking graph. I'm not really sitting in a very balanced position here. Not really sitting in a very balanced position here. It's some sort of maximum, and then tend to negative infinity. You can use some calculus to find this point. I'm confident that there is a maximum turning point there somewhere. Obviously, in this domain here, we're just dealing with a strictly positive value, as in the 2 factors. Let's go back to the sign analysis, which I'm not really writing in full here, but the 2 factors that will be positive are, only 1 factor will be positive. X plus 2 is positive because x is larger than 2. Yeah, x plus 2 is going to be positive in this region. But these 2 factors, x plus 1 and and 3x, are both going to be negative. Obviously, x plus 1's only, it's negative in that region, and x is negative in that region. So you've got 2 negative factors and a positive factor, not all multiplied together, but multiplied and divided. So that gives you a positive, a curve in the positive region. There's no further x-intercepts there, so you're just going to turn around, basically. It's like a U-turn, basically. Like that. That's terribly drawn there, sorry. I'm confident there'll be some sort of local minimum there. And then in this region, it's all negative, so it seems clear that it just behave itself nicely. It won't cross its own asymptote again. So the key question I was asked here was, how can you say that this is a horizontal asymptote? Well, it is. Okay, the key thing being that the curve is tending towards its asymptote here. The curve is tending towards its asymptote here. Those are the key places. Those are the key things to analyze in terms of its asymptote. So there is an asymptote at the line y equals 0. The line y equals 0 is the x-axis. Is the x-axis. So y equals 0 is an asymptote. Y equals 0 is an asymptote for this curve. I hope that's a bit helpful. Obviously, this relies on some year 11 work where you do that sign analysis and you were looking at the limits and understanding where asymptotes are. But now that you actually, when we studied this previously, that we didn't have calculus. Now you do have calculus. You can find the turning points there. There'll also be a point of inflection here somewhere, because obviously it's going to have to go from a positive concavity to a negative concavity there. So there'll definitely be a point of inflection somewhere here. There'll be a maximum there. I don't think there's going to be any other inflections, or there's obviously one minimum, one maximum. It would be interesting to analyze the range of this function, in that whether or not, depending on the y values of those two, there might be parts of the y-axis that this doesn't cover. There might be a gap there, as in depending if, say, this curve was above that, say, didn't end up, the local minimum there was higher than the local maximum there. There might be some y values that in the range that are not covered, but it might actually be that this has a range of all real y. Certainly, its domain is all real x without -1 and -2. Anyway, so it's quite an interesting graph, really. But the key how do you do this in a 1 mark, question in question 4? You really just looking at this, going, what is happening as x tends to infinity? You've got one x factor and two x factors on the denominator. It's tending to 0. is basically the analysis that you need to do there to come up with this being true. These are both being true, therefore giving A as the only answer. That's a very long answer to a fairly short question, but I thought you might want a quite full explanation of that. Okay, thanks a lot.